Welcome back, students. This video we're going to cover lesson 3-9. This is proving lines parallel. So, we're skipping 3-8. That'll be the next video I do. And it's because 3-7 and 3-9 go together. 3-7 we talked about parallel lines and transversals. So the lines were parallel, and so we talked about the relationship of the angles. In this video, we're going to talk about use the relationship of the angles to prove that the lines are parallel. So it's the converse to 3-7. All right, so we'll have some theorems at the top of the page, and then we'll go into some practice. So theorem 3-19, the converse of corresponding angles theorem. So if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. Let me get my stuff here. Okay, so let's do this. So we notice that we have the extra little arrow. That means that these lines are parallel. All right, so corresponding angles. So 1 and 3. So you got 1 and 3. So notice both are the top left. This is, again, same stuff we were covering in the last lesson. 2 and 4. So right here next to the top right. 5 and 7. So bottom left. I'm sorry, bottom right. And then 6 and 8. Bottom left. So if those angles are congruent, then A and B are parallel, and that's what that symbol means. All right, theorem 3.20, alternate exterior angles converse. So if two lines in a plane are cut by a transversal so that the pair of alternate exterior angles are congruent, then the lines are parallel. So if 1 and 5 are congruent up here, then A and B are parallel. Let me just do this. So remember, so we're saying 1 and 5. So 5 is at the bottom left, top right over here. And A and B are our lines, so they're both exterior. They're outside of A and B. So A to B would be like, that's the interior. Everything else is the exterior. All right, 3.21, consecutive interior angles converse. So if two lines in a plane are cut by a transversal, so that a pair of consecutive interior angles are supplementary, then the lines are parallel. So it says if 6 and 7 equal 180, they're supplementary, then A and B are parallel. Let's see. How much you guys love 6-7, see. So right here, 6-7. 6 and 7 are, so if they equal 180. All right, 3.22, so alternate interior angles. So we're looking inside here. They're mentioning 7 and 3. You could also say 2 and 6, but if these two angles are congruent, then A and B are parallel because those are alternate interior angles. And then theorem 3.23 is the perpendicular transversal converse. So if two lines in a plane are perpendicular to the same line, then they are parallel. So before we talked about if one of two parallel lines is perpendicular to a line, then the other line is perpendicular to that line. So this is just the converse of that. All right, scooching down. Example 1. Use the given information to determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So, an A we'll do in blue here. So we got 2. 2 is up here, and 8 is over here. So notice 2 goes with this line, A, and 8 goes with B. The transversal here would be L. In order for these guys to be parallel, see, notice that 2 and 8 are both inside or interior of A and B. 2 is above the transversal, 8 is below it. So these guys are alternate interior. They're alternate interior angles, and that would be A would be parallel to B. All right, so part B here is 3 and 11. So 3 and 11. In class, some of you guys picked this up right away. So notice, so 3 goes with L, 11 goes with M. The transversal is A. So we're just looking over here. Oop, sorry, we gotta. Let me see if I can make this work. Hold on. So trying again. So we're just looking at these two. Notice 3 is the bottom right. 11 is also the bottom right. So those are corresponding angles. So corresponding angles. And again, L and M. So we'll write it like L, M. So L is parallel to M because those are corresponding angles. All right, lastly, C. 12 and 14. So 12, 14. So 12 is sitting on the outside of A and 14 sitting on the outside of B. M goes in between them, so M is your transversal. And so if A and B are your lines, 12 is on the outside, 14 is on the outside. 12 is below the transversal, 14 is above the transversal. So these would be alternate exterior. And that's again A, making A parallel to B. Just to kind of, so for A and B, this is the interior. And then everything outside, see where 12 and 14 are, is exterior. If we're talking L and M, it would be in between these two. Everything to the outside of both of those would be exterior. All right, example 1 check. So you're going to use this up here for these. So I'm gonna help you with B because B comes from here. It does. You have your choices underneath, but B goes with these choices that are under C. So for A and C, you'll use these choices. B is talking about 3 and 10. So notice 3 and 10. 3 and 10. I'll just kind of circle it like that. Those are consecutive, and they're consecutive inside L and M. See, L and M. So consecutive interior for L and M, that's this. So B is gone from your choices here. That was over here. Those are consecutive interior angles for L to be parallel to M, but that was there for you. Just trying to clear up some confusion. So the other part of the example 1 check is for you guys. I'm going to scooch down to example 2. All right, so example 2, find the value of y so that E is parallel to F. So E is parallel to F. Identify the theorem or postulate you used. So first thing we want to notice, notice we have that red box. So if E and F are going to be parallel to one another, if E is perpendicular to D, then F would have to be perpendicular to D. And that was the theorem at the top of the page. That was theorem 3.23. That's known as the perpendicular transversal converse. So if a line is perpendicular to one line, if those lines are parallel, it's perpendicular to both. So that's what that says. So If we have a 90-degree angle on one side of the transversal, remember a straight line is 180, so the other side is also 90. So to solve for y, say 90 equals 4y plus 10. So remember, that's 90, that's 90. This side, that's the important thing about perpendicular is it makes everything the same. So this guy is going to equal 90. So 90 equals 4y minus 10. All right, so 90 equals 4y minus 10, plus 10, excuse me. So you're going to get y by ourselves, so we're going to subtract 10 from both sides. Our 4y comes down, equals, and then 90 minus 10 is 80. So we got 80 equals 4y. Now we're going to divide both sides by 4. Y equals 80 divided by 4. 80 divided by 4 is 20. So 20 makes this angle worth 90, and that makes these both parallel, because E makes E parallel to F, and makes them both perpendicular to D because of the perpendicular transversal converse. All right, flip it over. All right, we got an example 2 check. So notice this straight line. So we have two ways of solving this. What we did in class was, so if A and B are parallel, notice this angle and this angle are your alternate exterior angles. So they would be congruent. So put those equal to each other to solve for x. Plug it back in to make sure this whole thing, because both of these angles make up that straight line, they should equal 180. So there's your hints. You work the rest of that. So solve for, find the value of that angle so that those two lines are parallel. Example 3. Now, this is kind of hard to see, but this is a picture of some rowers. So to move in a straight line with maximum efficiency, rowers' oars should be parallel. Refer to the photo at the right. Is it possible to prove the oars are parallel? Justify your answer. So what you essentially have, so our oars are our parallel lines, or would be parallel lines. The boat is the transversal. So we have 124 degrees above the parallel line and 150 below. Now these are not alternate exteriors because it would have to be over here for that. But these two angles here, for these oars to be parallel, they have to equal 180. Because the consecutive interior would equal 180. So that means this plus this would equal 180. So 124 plus 50, well, that does not equal 180. So therefore, they're not parallel. So, and that's our reason, because those two angles are not supplementary, and therefore those oars are not parallel. Example 3 check. So you have essentially the same problem. It just looks a little different. These are consecutive interior angles. Hopefully you can see. Let me just see if this makes it a little more visible. There's your two angle measures. Nope, didn't help. 54 and 120 is what you're dealing with. All right, so you have 4 choices. Those are consecutive interior. That's my little hint for those of you that are listening. So you solve example 3 check, A, B, C, or D. Scooching down to the bottom to finish off the video here, the summary. So if two lines in a plane are cut by a transversal, so that the pair of consecutive interior angles is supplementary. So that's kind of what I was saying here. There's your answer to that. That should help you solve that. And number 2, I'll let you guys answer. Why is it important to know how to prove that lines are parallel using angles? If you have any questions, let me know in class. Until next time, we'll see you.